In the third problem, we will need to do hypothesis testing using the critical value method. Be careful, I'm going to define the method which you must use. In this case, in case of problem number 3, it's going to be critical value method. And if the method is defined, you need to follow, you need to solve this problem using this method. Yeah, because I need to test both, like your knowledge of critical value method as well as the p-value method. Okay. And obviously, if you don't use method which is defined in the problem, it's going to be some major deduction. Okay, let's say we have a report and we can see, as we can see, the average salary based on this report, the average salary of full professors in Canadian universities is 100,735. A sample of 30 full professors has a mean of 103,746. At significance 0.05, test the claim that full professors earn more than $100,735 a year. Okay, and from a prior study, the standard deviation of population is known to be 12,499. As we already discussed, we need to follow some certain steps to run this procedure. The first step is definition of H0, the null hypothesis, and alternative hypothesis. Okay, H0 in this case, that's something what we know about population, and yeah, we have that report, so which states that it is 100,735. Okay, so let's insert, let's say, mu, and it is equal to 100. So it's dollars. Yeah, so 100,735. Okay, and H1. So we claim that it's more than, yeah, so then we can just move it here and make this 35, and it is greater than, so this is our H1, and this is our claim. Yeah, so we are testing this claim, and this is right tail test, right tail test. So, and this is our step number 1. We define H0. We define H0. We define H1. So again, you can define those as I did it here, or you can define it as mathematical opposite. So both of those representation of H0 and H1 are good, as we discussed in quiz 2 tutorial. Okay, so this step is important. And quite often I see that this step is missing. Okay, it's very important to formulate H0 and your claim. Yeah, because claim, yeah, so that's what we're testing. Yeah, and H0 is going to be our preliminary conclusion. Yeah, so we are going to make some conclusion. We reject or we accept H0. Yeah. And again, based on that, we are going to make final conclusion about our claim. So that is why it's very important to formulate both. Yeah, so it's very important to formulate both of those because it kind of defines what we are going to do. Yeah. Okay, so then second step, we will define our alpha. Our alpha is 0.05. This is the right tail. That is why our critical value, we need to find such a z value which cuts the area of 0.05 from the right. So it means it cuts 0.95 from the left. So remember all those functions, they are calculating area and whatever is associated with those areas to the left, always to the left. So that is why we need to do some additional manipulations in order to make calculations for the area from the right. Okay, so in this case we are just going to take 0.95. Yeah, it's going to be normal normal standard distribution inverted. Yeah, so inverted 0.95. So this is our value. So how we can also calculate it? We can calculate it normal standard inverted from 0.05, but this is going to be negative. Yeah, so this is going to be that left tail. That is why here we will need to put minus, and here we go. It's absolutely the same value. Okay. Okay, so now the third step. Yeah, we have the critical value. We have our alpha set. So now we calculate test statistic. We calculate test statistic, and it is equal to the sample. The sample is 103,000, so that's the mean of the sample. So that's our x bar 746 minus mean of population, which is 100,735, and we divide by the standard deviation population 12,499 divided by square root of a sample, which is 30. Okay, so this is our test statistic, and our test statistic is equal to 1.32. Yeah, 1.32, and we are out. Yeah, so we are out of the critical region. Yeah, so we are out of the critical region. So this is step number 4. Step number 4. We are out of the critical region. We are out of the critical region. We do not reject H0. Okay, so we are out of the critical region. We don't reject H0. Okay, we don't reject H0. And the last step, step number 5. That's our conclusion. So if we do not reject H0, so we do not support our claim. We don't support our claim. We do not have enough evidence to support a claim that full professors earn more than $100,735 per year a year. Okay, so that's it. So that's how the final conclusion should look like. Okay, so again, like we reject H0, but yeah, so based on that, we need to make that final conclusion about the claim. Yeah, because we are testing the claim. So the H0 result, if we reject it or we don't reject it, so this is some kind of intermediate result. Yeah, so based on which we are going to make the final conclusion. Okay. So that's what I want to see. I want to see all those steps clearly like shown. If it's the critical value, I would like to see how we calculated the critical value. So the numbers, they shouldn't appear from the nowhere. You need to use, you must use Excel functions, proper Excel functions. I also need to see your H0, H1, and what you consider your claim. Also, it's good if you identify the type of the test, if it's the right tail, if it's the left tail, if it's two tail. So this is also important because in some of the quizzes I noticed that the wrong type of the wrong type of the test was used. Yeah, so it was kind of mixed. So the the critical value, let's say it was calculated for two tail, but the test was right tail, but then somewhere else like it was defined as left tail, so kind of complete mix. So that's what you need to demonstrate. So you need to clearly show what tail you consider. So what is your H0, what is your H1, so what is your alpha, what is your critical value if it's critical value method, so what is your test statistics, test statistic, and what you what conclusions what conclusions do you have? Okay, that's it. So this is problem number 3, hypothesis testing using the critical value method. Let's move on to problem number 4.